everyone, how are you all? I hope you are all doing fine. So as you all know that I have started the JEE Mains previous year session on which I was covering top 10 or 15 important previous year questions from different topics of mathematics. So as you all know, if you have watched this particular playlist, on the previous lecture I have taken upon the topic of straight lines. So with this continuation, I am starting with the topic of circles. So as you all know the importance of this chapter circles, so if you are someone who have prepared this particular topic or have covered straight line, circles and conic section, I would recommend you to come and start solving questions with me. So I can also guarantee you that what is the advantage of this particular series is basically by watching this particular playlist, I can guarantee you that there will be similar type of questions that will be asked in a JEE Mains question paper. Alright, so with that notice, let's get started with the today's topic of circle. Alright, so today's goal will be on the top 10 important previous year question on the topic of circles. Alright, so the very first question is on the screen. So if you're someone who haven't prepared the conic section well, I can recommend you that you can leave the conic section for now. But if you have not started circles, I would request you just start preparing circles. Okay, so because circles there will be simple question in JEE Mains examination, and if you are knowing the concept of circles, then you can definitely ace plus 4 marks. Alright, so that is a very beneficial step. Alright, so students, I would recommend you to cover the chapter circles and start solving previous year question with me, and these are the top 10 important previous year questions. So these kinds of similar questions will be coming up in your JEE Mains examination. So let's get started with the first question. The first question on your screen, I would recommend, so students who haven't covered this, so I would request all of the students to just pause the video at this particular moment and try out the problem, and in the comment section definitely tell me that how much are you getting on basis of this particulars. Okay, so the very first question is basically on the topic of circles. So it is on the topic of common tangents and normals. Alright, so it is asking me that the number of common tangents to the circle, and the first equation of the circle is given by this particular equation, and the second equation is given as. So what is my first particular purpose whenever I am given on the question, find the number of common tangents. Alright, so the very first question is to identify what is the relation between these two particular circles. That means by relation I mean to say that whether these two circles are touching each other, or they are intersecting each other, or they are not intersecting each other, or they are interior of the circles. Alright, so those are the four basic cases that can be formed whenever we talk about two circles. Alright, so and then comes the discussion of number of common tangents. So as a moral responsibility, let us first decode the first equation of circle. The first equation of circle is given as x square plus y square minus 18xy minus 18x, sorry, because circle doesn't contain xy terms. Alright, minus 15y plus 131 is equal to 0. So from here I have if you are knowing with the chapter of circles, then you can definitely say that from this particular equation the center of the circle is given by minus of g by 2 comma minus of f by 2. Alright, so if you represent this x term by g and this y as coefficient of the y term by f, then you basically need to represent the center as, so I'm writing the center of the first circle as c1. So this is circle c1, so I'm representing by this particular operator notation, and the center I'm representing by the coordinate notation of c1, and the center of the circle c1 is basically equal to, so you can directly write this is equal to 9 comma 15 by 2. So that's basically the center of the first circle. And we also know that if we need to find the radius of the first circle, the formula for radius, so let me write it clearly. Alright, so what does this particular thing actually implies? So the equation of a general equation of a circle is actually written as x square plus y square. Alright, x square plus y square plus g times of x plus y times of f plus some constant is equal to 0. Alright, in many notation of the book you will find 2g and this will be 2f. So in this particular notation the center will be, if the notation is something like this, the center will be minus g comma minus f. Alright, so minus g comma minus f, and the radius of the circle will be given by root under g square plus f square minus the constant, let us see. So this will basically give you the radius and the center of the circle. So if you haven't prepared the topic of circle, then I would recommend you that study this particular topic in much good understanding. Alright, because these are the very basic fundamentals from the chapter of circles, because in every question of circle you will be basically finding the center and the radius. So whenever I will be asking you the question of circle or regarding the equation of circle, you do need two particular things. That is, the first is the center of the circle and the second thing is the radius. So if you are given with these two particular values, then you basically can definitely write the equation of a circle, because the equation of circle is, what is the equation of circle? So equation of circle for center, if I am representing center as a comma b and the radius as r, then the equation of circle is basically, circle is a set of all points or the locus of points which has a fixed distance from a fixed point, that means x minus a square plus y minus b square is basically, and square root, if I take the square root, this will basically represent the distance between a variable point x comma y and a fixed point a comma b, and the distance is basically fixed, and that is equal to r square, that is the radius. So this is the basically a general equation of a circle. All right, so if you aren't able to get to this particular formula, that is minus g comma f, how this particular formula came from, so you can definitely this particular value you can take it in form of this particular format, that is x minus something whole square plus y minus something whole square is equal to r square, that is some constants part. Okay, so if you are able to express this particular equation or this particular general equation in this particular format, then you basically get to the center as well as the radius. All right, so let us find for this particular. So what we are doing for the radius of the first circle, it is given as, so 9 square is 81 plus 15 by 2, that is basically 225 by 4, and minus the constant. So what is the constant? That is 131. So if you calculate this value, all right, so if you calculate this value, so from calculation of this particular value, you can definitely do this particular calculation easily. That is, if I take 4 as a denominator, this will become equal to 324 plus 225 minus, so if you multiply by 3, it will become 525, 524. Okay, so if you calculate this particular in the square root of this, and the value will come out to as, okay, so the r1, the value of r1 will, so if you calculate the upper term, the numerator term, if it will definitely come out as is equal to 25 by 4. So you can definitely do this particular solution on yourself. This will become 545 minus 524 is basically 25 by 4. So the value will be, the radius of circle will be of course a positive value, that is equal to 5 by 2. So for the first circle, I got the value of the radius as well as the center or the coordinate of the center. And similarly, if we perform the second job for the second circle, so what was the equation of the second circle? The equation of the second circle was x square plus y square minus 6x minus 6y minus 7 is equal to 0. So from this particular value or the equation, the center of the circle is basically, let me represent the coordinate of the center of the second circle as C2. So this particular value will be equal to, so that is 3 comma 3. All right, so the values of the center of the, or the coordinate of the center of the second circle is equal to 3 comma 3, and if we find the radius of the second circle, that will be equal to square root of g square plus f square minus c, that will equal to 9 plus 9 minus of minus 7. Okay, minus of minus 7, because the constant part we basically assume the constant plus c, so that means this will become equal to minus of minus 7, and this will be equal to, so 18 plus 7, and this is equal to 25. So the value root 25 is equal to 5 units. So from these particular values, I got to the two important things, that is the center coordinate of the first circle and the center coordinate of the second circle, as well as the radius of the first circle and the second circle. Now, what are the different possibilities that can arise? Now, if the two circles are touching each other at only one point, okay, touching each other at only one point, then the criteria will be, so if it is center 1 and center 2, so the criteria will be equal to, this is radius 1 and this is equal to radius 2. So if the circle is touching at one point, then there will be three common tangents. Now for this particular case, you will find that r1 plus r2 is equal to c1 c2. That means the distance between the two centers is equal to the sum of the radii. All right. So let me check for the solutions. All right. So if I perform the r1 plus r2 term, so r1 plus r2 is basically equal to 5 plus, and the previous one is 5 by 2. So this will give me 15 by 2. Okay, so r1 plus the sum of the radius is basically 15 by 2 units, and also I need to find the center to center distance, that is c1 and c2. So for the first center, it was 9 comma 15 by 2. So 9 minus 3, that is equal to 6 whole square plus 15 by 2 minus of 3, that is again equal to, so that is again equal to 15 minus, sorry 15 minus 6 by 2 whole square. So this will again be equal to, that is 36, plus this will be 9 square by 4, 9 square by 4, yeah. So this will be equal to 81 by 4. All right. So from here, if you cross multiply, and this will be equal to like 144 plus 81 divided by 4 under root of this, and 144 plus 81 is equal to 225, and this will be again equal to the center to center distance is equal to 15 by 2 units. So what a miracle it is that the center to center distance is equal to the sum of the radii of the both the circles. Okay, sum of the radii. That means that this situation is corresponding to the situation when the circle touches each other at only one point. So whenever the circle touches each other at only one point, then we basically get three common tangents. Three common tangents. Okay, three common tangents. So this is a part of the answer. Okay, so this is a part of the answer. If circle, okay, please pardon my handwriting. I'm trying to improve it. Okay. If the circle touches at only one point, okay, then we have three common tangents, and with this, the right answer to this particular problem will be option number 3, option C. Alright, the three common tangents. So I hope this particular solution was clear. So you can definitely expect this type of problem will be coming up in your JEE Mains paper. Alright, on the question of common tangents. Alright, so with this, let us move to the next problem, and the next problem is very important problem that I would suggest to you, like if you haven't studied this topic of circles, and these are the types of questions that you must prepare before your JEE Mains examination. Alright, so this problem is saying that let the center of a circle be alpha comma beta, and its radius is basically less than 8. That means its radius is basically less than 8 units, and it is saying that 3x plus 4y is equal to 24, and 3x minus 4y is equal to 32 be the two tangents, and 4x plus 3y is equal to 1 is basically a normal to the circle. Then it is asking me for the value alpha minus beta plus r. That means you basically need to find the coordinate of the center of the circle as well as the radii of the circle, radius of the circle. I'm sorry. All right. So let me draw this particular circle C, and it is saying that the center of the circle is basically alpha comma beta. And what I can understand that this particular tangent and this tangent, alright, sorry, this particular tangent, so you can see this second tangent and this normal are basically perpendicular to each other. That means this tangent and the normal will be intersecting at a particular point. That means this normal is drawn, and that point where the circle cuts the, where the normal cuts the, like a surface of circle or the periphery of the circle, at that particular point only this particular tangent was drawn. So let me say that this tangent was actually drawn at this particular point, and the equation of the tangent is 3x minus 4y is equal to 32. Now, for the normal of a circle, you don't need to remember different formulas, as in case of parabola, as in case of ellipse, as in case of hyperbola. The important thing was that for a circle, the each and every normal drawn at every point on the periphery of the circle, it will definitely pass to the center of the circle. Alright, so from here you can definitely say that this is the normal. Okay, so this is the normal. So this will be basically perpendicular to each other, normal and the tangents are perpendicular to each other, and the normal will be definitely pass to the point C, the center of the circle, and let us assume that the other tangent was drawn at this particular point. Alright, so let me label this point as A point and this particular point as B point. Okay, so this is the other tangent, that is 3x plus 4y is equal to 24. Alright, so this is point A. Now we have to get to the value of point A. Alright, so what we can do in order to get to the value of point A, now let me choose different color ink. So I am solving for point A, then I have to basically equate this particular value of tangent, this value, and the value of the normal. That means I have to solve for the equation 4x plus 3y is equal to 1 and 3x minus 4y is equal to 24. So what can I do? I can multiply the first equation by 3 and second equation by 4 and then subtract each other So the first term, that x term, will get cancelled out. This will be 12x and this will also become 12x. And similarly, this is 9y and minus of minus, this is 16 plus 9, this is 25y. 25y is base equal to, this will be 96 plus 1 and is equal to 97. Alright, sorry, this will minus, sorry, very sorry, minus 96 plus of 3, sorry. All right, so this will become, oh, that is not 24, that is 32. So that's what the mistake I was doing. That is equal to 32. All right, so this is 32. So 32 into 4. All right, so this will be minus of 32 into 4, and this is equal to 128. So 128 minus 128 plus 3 is equal to minus of 125. So from here I get to the value of y as minus of 5. Okay, so y value is minus of 5, and similarly if I put y is equal to minus of 5, I will get the value of x as 4x is equal to 1 plus 3 times of y, that is 1 plus 15, and that is 16. So 4 is x is equal to 4. So x is equal to 4. So I got the coordinate of the point A. So the A point is basically 4 comma minus 5. So from point A, now it is basically saying that the point alpha comma beta will definitely lie on this particular normal, and from here then I can also deduce another equation, that is 4 alpha plus 3 beta is equal to 1. And if I need to eliminate in one kind of variable, then I can write beta as 1 minus 4 alpha by 3. Okay, so I did this particular manipulation. Okay, now what I can say, that the distance of this point alpha CA is basically equal to the perpendicular distance of the point C to this particular line, 3x plus 4y is equal to 24. That is also equal to the radius of the circle. Okay, so from here I can apply the distance approach. Okay, so I can apply the distance approach, that is the radius of the circle. Okay, so what I can do, that from alpha comma beta, so from alpha comma beta, the perpendicular drop on the line, that is 3x plus 4y is equal to 24 is equal to radius. Okay, so I can calculate the radius as, so the radius will be equal to, so we definitely know the formula, but whenever we basically take the perpendicular distance of a point on a straight line, the perpendicular distance of a point on a straight line is basically given by modulus of, you put this particular point in this particular equation of the straight line, that is 3 alpha plus 4 beta minus of 24 divided by the square root of x, coefficient of x square, plus square root of, sorry, square root of square of coefficient of x and square plus square of the coefficient of y, and then take the square root. That means that is square root of 3 square plus 4 square. All right, and this is the modulus, and if I put in place of beta, I put the value in terms of alpha, then I will get it as 3 alpha plus 4 times of 1 minus 4 alpha by 3 minus 24 divided by 5, and we need to take the modulus because radius should be a positive value. All right, so from here, this particular value will also give the radius, and simultaneously we can calculate the other radii as, that is the distance of AC. Okay, distance AC, so that will be equal to alpha minus 4 whole square plus, so square root of, we put the square root because this also implies radius, so alpha minus 4 whole square plus beta minus of minus 5, that is beta plus 5 whole square, and in place of beta, if I replace it by in form of alpha, that is alpha minus 4 whole square plus 1 minus 4 alpha by 3 plus 5 whole square. Okay, so we also get this radius, and now if you equate these both things, so if you equate these both, now the distance we need to just equate it. Okay, or you can do one other thing, that instead of calculating this particular, because these two equations will be little bit difficult to solve, because this has the equation which is degree, so you just need to check that whether this particular, because it has square root involved and this doesn't have square root involved, so this will make a like a calculation little bit difficult. So instead you can also do that, instead r can also be found out as, it will be equal to 3 alpha minus 4 times of beta minus 32 divided by 5. So you can also calculate this by in this particular format. All right, so if you do this, so from here if you also calculate and put beta in form of alpha, and then equate both the things, then on solving you will definitely get the value of alpha as, so you will solve this, so you will get a quadratic equation. All right, so why will you get a quadratic equation? All right, so the reason you will get a quadratic equation is basically there is modulus, so there can be two possible values. Okay, so that means that alpha can be equal to 1, and if you solve it, I have solved this on my rough. All right, so if you solve this, you'll basically get alpha is equal to 1 and alpha is equal to 28 by 5. All right, so sorry 28 by 3. So if you can solve this, you will definitely get alpha is equal to 1, and one of the value of alpha will be equal to 28 by 3. All right, so from here if you put alpha is equal to 1, the center will be equal to, the center is equal to 1 comma minus 1, and if you see the 1 comma minus 1, then the radius will be equal to, 5. All right, and if you put alpha is equal to 28 by 3, then you will get center as 28 by 3 comma 28 by 3 comma minus 109 by 2, and in this particular scenario you will get the radius as, so if you solve this for this particular scenario, you will get the radius as something approximately as 49 point, so 49 point something something, but it is very strictly mentioned that the radius is basically less than 8 units, so that means this particular case is rejected. So this particular case is rejected and this particular case is taken. All right, so from here I get to the value of radius as 5 and the alpha comma beta value is equal to 1 comma minus 1. So from here I need to evaluate the value of this expression. Alpha plus beta minus r is equal to, so alpha I got 1, beta I got minus 1, minus 5. So this value will be equal to minus of 5, and I need to calculate for this part, sorry, radius was plus of r, what I'm doing a mistake. Okay, so this is equal to 5, so the value will be equal to option number C. So the answer is option number C. Oh, very sorry, not option number C. So this is a very silly mistake that actually persons students commit. Okay, so very careful, because this is alpha plus beta, okay, alpha minus beta and plus of r. Okay, so be very careful while you are calculating it. Okay, I'm very sorry for I just misprinted. Okay, because my mind is basically reading one step ahead of what I'm actually writing. So this will become minus of minus 1, this is plus 1, and this will be equal to 7. So this is a very big blunder that people definitely make. Instead of solving the entire question correctly, they definitely make mistake in while attending the answer. So you must be very cautious while you are attending the answers. Like what is asked in the question, try to read it, try to read the question once again after you get to the values. Keep your nerves, okay, just be patient and have your keep your nerves quiet and just go on attending it. Okay, so that's the only thing that you can definitely do to avoid mistakes. So which is the option A is the basically the right answer to this particular problem. All right, so yeah, be careful of this particular type of mistake. Now let us move to the third problem, and the third problem is a problem on locus of a circle. All right, so this is saying that there is a point A, and the point A has a coordinate 1 comma 2, and the point B basically lies on this particular curve. That is, he said that it is a curve which we know that it is a circle. So it is saying the center of the locus, so center of the locus of point P. So point P basically, point P is a variable point which basically traces the point of a locus, and this particular locus has a center. So that means what kind of a locus can have a center? Because we know that if it is a locus problem, then it will be definitely, there will be some kind of general equation at your level. All right, so if you're solving for this general equation, then there will be kind of a equation that comes as circle. All right, because this will give you the intention that the equation of locus will also be a circle, because it is asking for the center of the locus. All right, so this kind of intuition you can develop once you are solving lot of questions. Okay, once you solve different types of problems, then you can definitely, this kind of mathematical problem solving approach you can definitely get on. All right, and it says that it divides the line segment AB in the ratio 3:2. All right, and it is saying that the center is basically C, that is alpha comma beta. Then it is asking you for the length of the line segment AC. All right, so let me do this. It's a pretty simple question. So it is saying that there is a point A point is given as coordinate 1 comma 2, and the B point has a coordinate. Okay, so I can write the for the coordinate of point B in, because this is a locus problem, so I will always recommend to write the variable point. If there is a variable point in place of a circle, you have to need to put a point on the circle and inform a variable, then definitely do it by the parametric method, that is r cos theta and r sin theta. So in place of that, to be more specific, it will be basically equal to alpha, or if you say the center of the circle as a comma b, so a plus minus r cos theta comma b plus minus r sin theta. So that will be the more generic format of writing the parametric equation of a point on a circle. I hope this particular thing is making sense. All right, so from here you can definitely get that this is equal to 4 cos theta, and the other is basically equal to 4 sin theta. So this is the line segment AB, and it is saying that the locus of the point P, so the point P basically, which is the locus, so let me, because it's a locus problem, and we know that to represent the variable point is basically h bar comma k. So the locus, so P is a locus, and it divides the line segment AB in the ratio 3:2. All right, so from here I can get to the coordinate of point P. I can get to the coordinate of point P by using the section formula, So what will be the x coordinate? X coordinate 2 into the 1. So 2 plus 3 times of 4 cos theta divided by 2 plus 3, that is 5. And similarly for the y coordinate, it will be equal to 4 plus 3 times of 4 sin theta by 5. Alright, so this will give you this the coordinate of the point P, which is basically dividing the line segment AB in the ratio 3:2. Alright, so from here, now how to eliminate and get to the particular solution. So let me firstly get to the variable term. The variable terms involves the parameter, that is theta. So I need to eliminate theta, and the best way to eliminate cos theta and sin theta from any expression is basically square cos theta, square sin theta, add them, and you will get the value is equal to 1 for respective values of sin theta and cos theta. Alright, so from here you can write cos theta as equal to 5h minus 2 divided by 12. So this is the value of cos theta, and similarly sin theta from here it will be equal to 5k minus 4 by 12. Now what I can do, I can square the both the terms. I can square sin square theta plus cos square theta is equal to 1, and if I do so, then I will get the value as, so in doing so I'll get to the value 5h minus 2 by 12 whole square plus 5k minus 4 by 12 whole square is equal to 1. So this is the equation of a circle. How it is equation of circle? Because you have seen that the equation of circle must have the coefficient of x square and y square as 1. So let us make it. Okay, so from here if you take, so what you can take, the coefficient is common is 5 by 12. So if you take 5 by 12 common, so you will get the values as, so if you take common, then you will get h minus 2 by 5 whole square. Okay, so if you take 5 by 12 common, you will get h minus 2 by 5 whole square plus k minus 4 by 5 whole square is basically equal to 12 square by 15 5 square. Okay, so this is the radius of circle, and we know that it is a locus problem. So the equation of the locus, in place of h and k, you just need to put x and y. You need to put x comma y. So this will give you the equation of the locus. Alright, so if this is the equation of the locus, which basically represent a circle, and this is a circle, and the question you are asked to find the center of the circle as alpha and beta. You have said that the center is C and this alpha comma beta. So from here you can say the alpha comma beta value is basically equal to 2 by 5 comma 4 by 5. Now you need to calculate the value of the length of the line segment AC. So that by using distance formula, I can calculate it as, so A point has x coordinate 1 minus 2 by 5 whole square plus and the 2 minus y coordinate of A is basically 2 minus 4 by 5 whole square. So from here you will get it as 3 by 5 whole square plus 4 by 5 whole square is equal to, so this is equal to 1. So this is basically equal to, if I am not wrong, okay, oh very sorry, this will be equal to 10 minus, oh 6, this will be equal to 6. So very sorry for my end. Okay, again I am doing calculation mistakes. So you must be very careful while you are actually attending the paper in examination point of situation, because you might go on making error instead of solving the entire question properly. So this will be not equal to 1, this will be equal to 9 plus 36 divided by 5. So 9 plus 36 square root of 9 plus 36, so that is equal to root 45. So root 45 will be equal to 3 root 5. So 3 root 5 by 5 units. So 3 root 5 by 5 units. So let us check for the answers. So the answers do have an option. Yeah, it has option number A, which is 3 root 5 by 5 units. So that is the right answer to this particular problem. I hope this is a pretty simple question, but these types of questions are very important because this will teach you like how to solve parametric equation. Okay, these types of question will teach you like how to take the parametric coordinate and eliminate to get to the required equation of a locus, problems. All right. So this is an important set of problem. I would recommend you to practice this type of problems. All right, for the JEE Mains purpose. Alright, so let us move to the fourth problem, and the fourth problem is again a similar kind of a locus problem. Okay, but it is little bit in a different manner we can solve it. So it is saying that in a line segment AB, and the line segment is named as AB, which is of length lambda, which moves such that the point A and B remains on the periphery of circle of radius lambda. So there is a circle which has a radius that is equal to lambda, and there is a line segment, okay, which is basically a chord because it is not equal to the diameter. Okay, a chord which is not the diameter, because the length of the line segment AB is also equal to the length of the radius. Okay, so that means let us assume this is a chord AB, all right, which has a length lambda. And we know from initial or early classes of class 9 geometry, then whenever we drop a perpendicular from the radius center, so let me represent the center of the circle. Okay, so let the center of the circle be O. We don't know about the coordinate of the center of the circle, so let us represent the coordinate or the center of the circle by point by O. So we know that whenever we drop a perpendicular on a line segment or a chord of a circle, we basically divide the circle or bisect this line segment. That means basically A and B is divided into two equal halves. So this is a perpendicular drop. And let me represent this particular point as point M. So, or maybe point C, it will be better. So let me use the point C. All right. So let me use, this is point C, and the length of the line segment AB is basically lambda. Now it is asking me that there is a point. Now the locus of a point that divides the line segment in the ratio 2:3 is basically a circle. Is again a circle of what radius? That's the question is asking you. So it is very pretty simple. So let me write the locus as, so the locus point, let me represent the locus as M. And the M divides the line segment AB in the ratio 2:3. So if I look at this particular problem, so if I look at this particular problem, okay, so if I look at this particular problem, so from division of the line segment AB in 2:3 ratio, what I can say of the value of AM. So if you ask me for the value of AM, I can say this AM is basically 2 by 5 times of lambda. And similarly, if you ask me for the distance BM, it will be 3 by 5 times of lambda. All right. So now in triangle OCM, if I apply by Pythagoras theorem, okay. So if I apply the Pythagoras theorem, okay, uh, we will basically get it as OM, or let is not call, okay, we will use the apply or the principle of right angle triangle, that is a sum of the square of the hypotenuse is equal to the sum, the square of the hypotenuse is equal to the sum of the square of the other two sides. Alright, so that's basically the Pythagoras theorem, or you can call it like or it was actually founded by some ancient Indians. Alright, so let me give credits to all our Indians mathematician, and then it will be equal to cm square plus co square. Okay, so now we are in a basically a position to basically say that co is equal to, so if I ask you that what is the value of co, okay, so you will say me that now since this question has a catch, now in order to get to the value of co, you basically need to assume something. Now since this circle has mentioned nothing about what kind of circle it is, so we are in a good position or free to assume our circle center of the circle as 0 comma 0. For our simplicity, we can definitely do that, or you can definitely assume the center of the circle as some fixed point alpha comma beta. But why do we need to use the center of the circle as origin? Because this will minimize our calculation. This will definitely minimize our calculation. So from here, if I assume this particular as 0 comma 0, then I can get to the value of OC as, so this CB is basically lambda by 2, and this is lambda. So I can definitely use the distance formula for this particular triangle, for triangle OCB. Then I will get the OC value as, so the OC value, OC square is equal to lambda square minus lambda by 2 whole square. So that will be equal to lambda square minus lambda by 4. That will be equal to 3 lambda square by 4. Alright, so that is equal to OC square. So let me put this OC square over here, and CM is equal to, so CM value will be equal to lambda by 2, because AC is equal to lambda by 2 and AM is equal to 2 by 5 lambda. So that will be equal to 2 by 5 lambda. So lambda by 2 minus 2 by 5 lambda is equal to, so if you solve this, will be equal to, so you can cross multiply, this will be equal to this will equal to lambda by 10. Okay, so this will be equal to lambda by 10. So from here, lambda by 10 whole square plus 3 lambda whole square by 4. Okay, 3 lambda square by 4. So that this value will turn out to be, that is the OM square. Okay, that is the OM square. So the value of OM, and what is basically OM? So OM is basically the locus point. So let me represent the M coordinate as a variable coordinate x comma y. So if you are said that what is the distance OM, now since we assume that this will play the advantage role, that since we assume the center of the circle as 0 comma 0, this will give you that added advantage that OM is basically equal to x square plus y square, and this is also equal to lambda square by 100 plus 3 lambda square by 4. Okay, now if we add this will be equal to, so we need to just multiply by 25 in this particular on both the sides, numerator and the denominator. This will be equal to 76 lambda square by 100, and this will give you the equation of the circle, which is basically equal to x square plus y square, or the locus of that particular desired circle, that is x square plus y square, is equal to, so this will be equal to, okay, so if you cancel out, you can cancel out by 4, so this will be equal to 25 and this will be equal to 19, so this will be equal to root 19 by 5, so root 19 by 5 lambda whole square, and this will give you the radius of the circle, the radius of the locus of the radius of the locus, that is basically circle, will have the radius r as root under 19 by 5 lambda, root 19 by 5 lambda. Okay, so the radius will be equal to root 19 by 5 lambda, so root 19 by 5 lambda, and that with this the right answer to this particular problem will be equal to option number D. I hope this problem was clear. This is a very simple problem. Okay, so you can definitely think like, how did I approach this particular problem? Instead, now whenever I was applying this particular problem, when I was doing in first time, I was thinking ki what will be the value of the center, because if I get to the coordinate center, then I can definitely solve one. Then this came to my mind that since it is nothing mentioned about the circle, so we are in a free position to establish or to take an assumption of the center of the circle by our means. So what is a simple center coordinate? That will basically equal to 0 comma 0, and that's what we assumed in this particular problem. All right, so with this, let us move to the fifth problem. All right, so the fifth problem says that, so the fifth problem basically says that if the tangent at a point P and Q of the circle basically meets at point R, then what is the area of the triangle PQR? So this is a very set procedure kind of a question. Okay, so this is a very set problem. The circle, okay, so we need to draw the circle, and there is a point P. Okay, so let me assume the point P as this. Okay, so I will write this point as P point. This is the center O, and the Q point, okay, Q. So if we draw the tangents at this point P and Q, they intersect at point R. So we need to find the area of the triangle PQR. So we need to find for this particular area, this particular shaded area. All right. So, and the coordinate of R is given as 9 by 4 comma 2. Now, if you are someone who have prepared the topic of circle, then you can definitely write this particular equation of this line PQ. Okay, or you can do one important thing, that is take out the equation of the circumcircle. Okay, or you take out the equation of circumcircle. Okay, so let us write the equation of circumcircle. Okay, now what is this particular circumcircle? That is basically a circle which will basically enclose this entire triangle. Okay, so if I basically go on, so oh, very sorry, why I'm looking for circumcircle. All right, let's not do it by the circumcircle method. Okay, we can definitely uh, not try out by circumcircle method, or we can definitely do it by just by finding the coordinate of a P and Q. That will be better, easy. Okay, so before doing so, let us get to the equation circle. So the equation circle is basically x square plus y square minus 2x plus y minus 5 is equal to 0. So from here, the center of the circle, the center, that is 0 or the O, is basically 1 comma minus 1 by 2, and similarly the radius will be equal to 1 plus 1 by 4 minus or minus 5, that is plus 5. So this will be equal to 25 by 4, 25 by 4 square root, and that will be equal to 5 by 2. So the radius of the circle is equal to 5 by 2, and the center is equal to 1 comma minus 1 by 2. All right, so from here now we can apply the concept that in order to find the area of a triangle. Okay, so in order to find the area of the triangle, what I need to find out is basically, so we can use the Heron's formula in this particular scenario. If we get to the values of the sum of the sides, like all the length of the sides, then we can definitely apply the Heron's formula for calculating the area of a triangle. Or we can do other thing, that is basically in order to get to the area of a triangle, we just need the hypotenuse and the base length. So what I'm in a motive to calculate is basically drop a perpendicular from here and then calculate the value of this PQ. Okay. Also if you are someone like who has remembered the formulas, because what I was thinking that instead of solving this particular by taking out the values, what I was suggesting is that if you can definitely find for the, now there will be a lot of approaches. Okay, now since r point is given, okay, the very first thing that you can do is basically get to the chord of contact, and we know that the equation of chord of contact is basically t is equal to 0. If you know what is t is equal to 0, then you are basically, this is very similar to the way how you used to find for the equation of a tangent at that particular point. Okay, so you will get to the equation of PQ, and once you get to the equation of PQ, you will put that equation in this particular circle to solve for it, and you will definitely get to the values of point P and Q. You will get to the coordinate of point P and Q, and when you have the three coordinates, then you can definitely find the area of a triangle. So that's what my motive is. So let me go and find out by, or also if you know a formula, okay, so there is also a formula that I will write it down, but I won't suggest to like remember formulas. Okay, area of this particular triangle PQR. So if you have read the theories like much nicely, then you will know that this particular formula is given out by r, the radius of the circle, into the length of the this tangent, the length of the tangent whole cube, by r square plus l square. So this is a very short trick that was actually, so if you solve it, and then you can definitely remember this formula. But I won't suggest to remember the formula, where a is basically calculated as root under s1. So you put the point s, this r on this equation circle, you get to the value of the operator s1, and then take the root, you'll basically get to the length of the tangent. Okay, and then put in this particular formula, you will get to the area of the circle. But that I won't like suggest you to remember like formulas, because it is like a, you might forget this particular formula in the examination. Okay, so there are a lot of approaches. Okay, but the approach that is very suitable is basically get to the equation of chord of contact. Okay, or basically the chord of contact. Okay, that is basically t is equal to 0. So you know what is t is equal to 0, that in place of x square you have to put x comma x1, that is x by 9 by x into 9 by 4 plus y into 2, and in place of x you just need to put minus of 9 by 4. Okay, that is 2 into x minus 9 by 4 plus y minus 2. Okay, so in place of, like for the transformation, basically x minus h by 2, sorry, that will involve a 2 over here, so by 2, and is equal to 5. Okay, so from here if you solve, you'll basically get to the equation of the PQ. Okay, so from here you will get to the value of PQ, the equation of PQ, and if you solve the equation of PQ with the circle equation, you'll get two values of a, like in one variable if you solve, you'll basically get a quadratic, and if you solve for quadratic of x, you will get two values of x, one for the x coordinate of P and one for the x coordinate of Q. And similarly, if you put the x in the values of the two different values of x in the circle equation, you will get to the two different values of y, which will correspond to P and Q. So you get the P and Q coordinate, and then definitely apply the area of the circle, sorry, the area of triangle as half times of modulus of this is this particular value, that is x1 y1 1, x2 y2 1, and x3 y3 1, and take this determinant and take in the mod and divide by half or multiply with half, then you basically get to the area of the triangle. Okay, so that's also a very simple purpose. Okay, so I would recommend you to solve this particular approach in your homework. Okay, to solve this particular approach in your homework, because I'm in a lack of a time, so I'm solving by the equation direct formula, that is r square plus l r square r into l cube by divided by r square plus l square, and this is equal to the area of triangle PQR. So this is equal to the area of triangle PQR. All right, so from here the area of the triangle PQR, so we know the area radius is basically 5 by 2, and what is the length L? L is basically, if you put the point 9 by 9 by 4 and 2 in the equation circle, that will be equal to 9 by 4 whole square plus 2 whole square minus 2 into 9 by 4 plus plus 2 minus of 5 is equal to, this will be equal to, if you solve, this will be equal to 5 by 4 units. So this will give you 5 by 2 into 5 by 4 whole cube divided by 5 by 2 whole square plus 5 by 4 whole cube, and if you solve, you will find the area of the triangle will be equal to 5 by 8 unit square or square unit. Okay, so this will be the area of the triangle, that is 5 by 8. Okay, so the area of the triangle PQR is equal to 5 by 8. Okay, so with this the correct answer will be option number B. Now I will definitely ask you to solve it by this particular method. Okay, now don't just like overthrow this particular method, like it is very good, but try to solve it, because there will be a lot of challenges you will face in while calculating. So I need to establish that you are definitely solving it on your own. Okay, so do solve this particular problem on your own, and definitely mention in the comment section of this particular video. That's the only thing that you need to put a commitment. As a commitment, show that particular dedication, because in these previous videos what I'm uploading, I am not even getting any reply from you students. All right, so the next sixth problem of this particular series of circles is a set of all values of a square for which the line x plus y bisect two distinct chords drawn from the point P on the circle. This is the equation circle is equal to. So it is asking me for the set of values of a square. So let us try to figure out what the situation has to say. So this is a circle. Okay, so this is the equation of circle, which is basically given by this particular equation. Okay, so this is a circle, and it is saying me that this particular line x plus y is equal to 0. The x plus y is equal to 0 basically divides, bisects, oh sorry, it says that it bisects two distinct chords drawn from point P. So two distinct chords, let me draw a chord from point P. So the point P is equal to 1 plus a by 2 and comma 1 minus a by 2. Okay, so it is saying that the point P, so it is saying that the point P is basically 1 plus a by 2 and 1 minus a by 2. Okay, and let me be very clear from the equation of circle. It is the circle equation is x square plus y square minus 1 by 1 plus a by 2. Okay, x minus okay 1 minus a by 2 into y is equal to 0. So from this particular equation of circle, the center of the circle will be equal to, the center of circle will be equal to 1 plus a by 4 comma 1 minus a by 4. Okay, so this is the center of the circle. And if I represent, because it is saying me that the set of all values of a square for which the line bisects two distinct chords drawn from the point P. Now for simplicity, because this 1 plus a and 1 minus a by 4 is basically big terms, so for simplicity let me represent this center as h comma k. And if I say this center as h comma k, then the point P will be basically 2h comma 2k. So the point P will be equal to 2h comma 2k. And we have a line, so the line is basically x plus y is equal to 0, which basically divides the chord or bisects the chord PA and also another chord that is PB. Okay, and if this is a point of intersection, then definitely it will lie on the this particular line. So let me have this point of intersection as lambda comma minus of lambda, and this point P is h comma 2h comma 2k. Okay, and since a and this particular point of intersection and this point of intersection and P are basically equidistant, that means they are equidistant. So let me also, now we know that whenever it is an equidistance, basically a case of chord at a center, chord with a given center. Okay, so chord with a given point, equation of this particular chord will basically given by t is equal to s1, a chord with a given midpoint, that is the formula. Okay, so that is t is equal to s1. So if you know that in place of just in place of the line equation is basically x minus y, sorry, um, not the line equation, I mean to say that in this particular circle equation, that is for t, we are firstly finding out for t. So this will be equal to x minus y lambda, because and minus of 2h, we have this as 2h, this particular thing is 2h into x plus lambda by 2, and minus of 2k y minus lambda. Okay, y minus lambda by 2 is equal to 0. So which will basically give you the equation as 2 lambda square. Okay, so this will give you the equation that is 2 lambda square. Okay, so if you solve this, this will give you the equation 2 lambda square minus 2h 2h into lambda plus 2k into lambda. Okay, oh sorry, so not equal to 0, so that's a mistake. Okay, this is equal to this particular thing. Okay, so in place of 0, whatever and 0, that is basically the value of s1. So the s1 is equal to 2 lambda square minus 2 h lambda plus 2k lambda. Okay, so that is the value. That means now since lambda, now since sorry now since so lambda is basically a function of h and k. Okay, so lambda is a function of 2h and k, because for lambda this particular value, that is lambda, satisfy the chord equation as well. The chord equation, I mean to say the AP or the AB chord or AAP chord, okay, because we are putting for AB. So if this particular thing satisfy the chord equation, then this particular value will yield the equation that is 2h minus 2k multiplied with lambda minus minus, because this is the equation of the chord AB and this is the equation of AP. This is the equation, okay, the equation of chord with a given midpoint is basically given by t is equal to s1, and in t is equal to s1 this is the equation, and we know that the point P will definitely satisfy. Then in plane I just put the coordinate P, that is 2h comma 2k, and in doing so I will get the values as minus k is equal to x y minus lambda, okay. This will imply 2 lambda square plus 4k lambda, okay, minus 4h lambda plus h lambda minus k lambda plus hx plus ky is equal to 0, and in doing so this will give you a quadratic in lambdas, okay. So 2 lambdas whole square plus lambda multiplied with, okay, multiplied with, so if you do so, then this will multiplied with 3k minus 3h plus ky plus h into x plus h into x is equal to 0. So this is a quadratic equation. So as you can see, this is a quadratic equation, okay. The equation is quadratic, okay, quadratic in lambda. Now since this equation is quadratic in lambda and it says that there are two values where this particular line, this line x plus y basically intersect, that means these will have two values of lambda, that means it will have two real roots, which is basically possible when the discriminant is greater than 0. So if you solve for discriminant greater than 0, now since this question is very lengthy problem, okay, I have done it on my rough, that's why I'm saving the calculation step. But for you, when you are trying on your own, then definitely solve this particular problem properly, okay, because I have done the calculation. I'm just saving up the steps because I don't have much page left, okay. So this will basically yield you 9 times of k minus h whole square minus 4ab, so 8 into ky, okay, plus hx will be greater than 0. Now if you solve this, you will get again a quadratic in you will get a second degree equation in h and k, okay, and that particular equation, when you put the value of h and k back into the equation in form of a, you'll basically get for the a square. So if I represent a square as t, so if I represent a square as t, then I will get a equation where involving t, and that equation is basically, so if you put this and solve, okay, there will be lot of steps, okay, involved. So if you solve this, this will be equal to 7 by 8 plus t plus 18 into 1 minus t by 6 is less than 0, okay. So this, if you solve this, will be equal to less than 0, and from here if you solve this particular equation, this is a linear equation, you'll get 4t is greater than 32, that is t is greater than 8. So if you solve this, you will get the range of value as t greater than 8, and in place of t you put a square, so this will be basically a square greater than 8. So you are in the question, it is basically asked that what are the set of all values for which a square, so a square is basically greater than 8, and that will imply the option number D is the right answer to this particular problem, okay. So this is a very lengthy problem, okay. So I can understand how lengthy this problem is, because after you are getting the equation of chord of contact, I mean the chord with a given midpoint, then you put the value of this particular value, then if you put, and then you get a quadratic in lambda, and for lambda you know that there will be two basically points of lambda which will yield two real roots, which is only possible when the discriminant is greater than 0. So that's how you basically need to proceed for this particular problem. I hope this particular problem is clear, okay. So this is a very important type of problem that you must prepare for your JEE Mains examination, okay. So this is must, okay. So with this, let us move to the seventh problem, and the seventh problem is a very important problem, okay. So if you are understanding this particular problem with a visualization, then only you are basically able to solve this particular problem in the examination. So it is saying that there is a circle which is obtained by rolling the circle, okay, that there is a circle C1 which is basically obtained by rolling this particular circle upward 4 units to the tangent, 4 units on the tangent t to it at the point. So if the tangent is drawn at the point 3 comma 2, then in on the tangent you roll this particular circle by 4 units, then you get a circle C1, and C2 is basically the image of the circle C1, okay, in that particular tangent. So it is saying that, so if you have a circle like this, okay, so if you have a circle like this, and if you draw the tangent, okay, at 3 comma 2, and if you roll the circle, okay, by 4 units, so you basically shift this particular circle by 4 units, okay. So what is meant by shifting of circle by 4 units? So that is basically the concept that you must try to understand, that whenever you basically shift a circle by 4 units, so this is the distance, okay, so this is the distance which is moved. And what is the formula for distance moved by the circle? And if you need to represent, or you want to relate it with the radius of circle, that will basically equal to radius plus the distance moved divided by okay, so the distance moved and divided by the circumference of the circle. Okay, no, not the circumference, sorry. Also you can do in the form of circumference, because the total distance moves. Okay, you can do like this. Okay, so if you cut this particular length, so it is moved by 4 units. So that is the important thing that you must understand. Okay, so after rolling the circle, after rolling the circle by 4 units, what should be the new center? Okay, so you can see that after it is circle has rolled, so for one complete rolling, it basically completes a distance which is basically 2 pi r, that is the circumference of circle. Okay, now if you assume the circle was in this particular position, so it completes 4 rolling, so sorry, 4 units it is moving on rolling. Okay, so you can definitely solve it. First basically let me get to the circle. So circle equation is basically x square plus y square minus 4x minus 6y, okay, plus 11 is equal to 0. Okay, so that is the equation of circle. Okay, so from the equation of circle, let me get to the center. So the center of this particular circle, that is C, is basically 2 comma 3. Okay, so the center was 2 comma 3, and if the center is 2 comma 3, let me find the radius, and the radius will come out to as 4 plus 9 minus of 11, that will give you root 2. Okay, so that is the radius of the circle, that is root 2. Now what I wanted to imply is that whenever you move by the circle by 4 units, that means this particular distance is 4 units. Okay, all right, so what is the new increment? What is the new increment in the distance? So that particular distance divided by the radius, that particular distance divided by the radius is basically the new increment in distance. That's what I am speaking of. Okay, so again try to understand rolling by 4 units. Okay, so it is saying that this particular statement has a very great impedance. Okay, that is upwards 4 units. Okay, it is obtained on rolling a circle 4 units. Okay, so the after rolling by 4 units, so 4 unit rolling is basically for one rolling you complete 2 pi distance. Okay, so it is like 2 pi, and that's how you complete basically 4 unit rolling. So that the increment in radius will basically given by, so if you divide it by r, so that's how the increment you will get in the radius. Okay, so for the new coordinate, so from here I can say that after rolling the circle, after rolling 4 units, okay, the center C1 will become, that is 2 plus, so what is the distance it has covered, that is 4 by root 2 comma 3 plus 4 by root 2. Okay, so that is that new center. Okay, because this particular is the increment in the x coordinate as well as the increment in the y coordinate. Okay, because this circle has entirely moved upon by 4 units. Okay, I hope these particular things must be clear. Okay, or if not, you can also take a help of like a coordinate geometry. So if I say that there is a one particular point that is ordinate, okay, that is 4 0 comma 0. Now if the origin has shifted to a new point, that is 4 comma 4, so what is the increment in x? So the increment in x is simple and it is 4, and similarly the increment in y is basically again equal to 4. Okay, and if you say that there is an increment in the distance, if it is moved by straight line, and there is an increment in the distance of, what is the distance increment, that is 4 root 2. But how you get to the increment in distance in x, that is basically 4 root 2 divided by root 2. Okay, divided by root 2, so that's the increment you basically get in x. Okay, and similarly the increment that you get in y is also equal to 4 divided by root 2. Now how do you know what is the root, why the root 2 factor comes from? Because if it is moving by, now since this is moving in a straight line fashion, and the equation of straight line is basically x is equal to y, which basically fetches a slope of 45 degree, and that 1 by root 2 factor comes from the sine 45 and the cos 45 term. Okay, so I'm trying to understand that whenever this particular coordinate of a circle actually moves, so for example the coordinate of circle was 2 comma 3, and it is said the circle has moved, okay, along this tangent. Okay, so a tangent will basically a straight line. Okay, so tangent is basically a straight line. All right, so also we need to get to the equation of a tangent before finding it out. Okay, so we need to find the equation of tangent. So equation of tangent at 3 comma 2 will be equal to t is equal to 0. So in place of 3x plus 2y minus 4 plus 3 by 2, okay, minus 6 y plus 2 by 2, okay, plus 11 is equal to 0. So if you solve for this will be equal to 3x plus 2y, okay, minus of 2x minus 6, and this will be minus 3y minus 6 plus 11 is equal to 0. So if you solve this will be x, and this will be minus y. So x minus y, and some constant term will be there. So this will imply the slope of this particular straight line is equal to the slope of the straight line by which it is basically moved is basically equal to 45 degree. The slope is basically 45 degree. So if there is an increment in distance by 4 units, so what is the increment in x-axis? What is the increment in y-axis? That will be the increment divided by root 2. So the root 2 factor definitely comes from. So the root 2 factor definitely comes from this particular sin theta and cos theta parameter. I hope this particular expression is clear. I tried my very best to explain this particular parameter. All right. So I hope this particular explanation is clear to you. Okay. So with this, you can definitely get to the center. Center will be basically 2 plus 2 root 3. Sorry, 2 root 2. Okay, center is basically 2 plus 2 root 2 and 3 plus 2 root 2. So that is the center of the circle C1, and we know that B is basically the center of the second circle. B is the basically second circle, that is C2, which is basically the image of C1 in the tangent T, in the tangent. Okay, so the equation of tangent we are basically clear. So we need to find for the equation of tangent. So let me find for the equation of tangent. We already find the equation of tangent at the point not A, because A is a different thing. So the at 3 comma 2, so we have already find the tangent value at 3 comma 2, it is basically x minus y. So we have to only calculate for the constant. The constant part is minus 6 minus 6, that is minus 12, plus 11, that is minus of 1. So that will be equal to 1. So that is the equation of tangent. And for circle C1, so this is a circle C1 which has a center 2 plus 2 root 2 comma 3 plus 2 root 2, and this particular center, if it is reflected around this particular tangent, that is x minus y is equal to 1, then you basically get the center point of the circle C2. Let this is circle C2. So if it is touching this particular point, then it must touch this particular point as well. Okay, so that's how the image of a circle is obtained. So that's how the image of a circle is obtained. Okay, so this will be point B and this is A. So B is basically the point of reflection, that is of the A. And in the question it is asked for, we are basically in the question you have to find here that if it is said that an M and N are respectively the feet of perpendiculars drawn from A and B on the x-axis, then the area of the trapezium which is basically found out. So if you put, and if you then drop a perpendicular on the x and y axis, you will basically get a perpendicular, I mean get a quadrilateral, and that particular quadrilateral is basically a trapezium, and you need to find the area of the trapezium. So let us find the point B. So the point B basically is found out by the image formula. So we know that whenever a point is reflected above a straight line, the image formula is given by x minus a by the coefficient of x equal to y minus that particular point divided by the coefficient of y is equal to minus 2 times of, put the value of that particular point in the equation of the straight line, divided by the square of the x coefficient and the square of the y coefficient. So that's how you solve it. So x minus 2 2 plus 2, okay, divided by 1, because the equation of the line is 1, the coefficient of x in equation of line is 1, and y minus 3 minus 2 root 2 divided by 1 is equal to minus 2 times. So we put the value, it will be equal to minus of 2. If you put this particular value, it will be equal to minus 2 divided by 2, and that is equal to 2. Okay, so you get minus 1, and minus 1 into minus 2 is equal to 2, and from here if you solve, the x value will be equal to 4 plus 2 root 2 comma, and the y value will be equal to 1 plus 2 root 2. So that is the coordinate of point B. So you got the coordinate of point B. And now if you get the coordinate of point B, you need to, you just get a quadrilateral. Okay, so you get a quadrilateral which is basically a trapezium. So trapezium, the formula for calculating the area for trapezium is half into sum of the parallel side multiplied with the distance between the parallel side. So that is equal to half into what is the parallel sides. Okay, so you just need to visualize it. Okay, so the coordinates are given as, so if you just visualize it, it is basically 2 comma 2 plus 2 root 2. So it is greater than, so it is greater than 4. Okay, 4, and the value 3 plus 2 root 2, that is greater than 5. Okay, so something like this. Okay, so the A point over here, so let us assume the point A is over something over here, and similarly the point B is 4 plus 2 root 2, that is greater than 6. So it will be over something like over here, and 1 plus 2 root 2 is basically greater than 3, so something over here. Okay, so like this. Okay, so or instead also, if you are not able to visualize it, you can directly draw it and then visualize, and from here you will get the sum of the parallel sides is basically 4 plus 4 root 2, and the distance between the parallel side will be equal to 4 plus 2 root 2 minus 2 plus 2 root 2 in bracket, okay, and this will fetch you the result, that is 4 into 1 plus root 2 square units. That is the area of the trapezium. So that answer to this particular problem is option number B. Okay, option number B is the right answer to this particular problem. I hope this particular discussion was very clear. All right, so with this, let us move to the next problem, and the next problem is again a very important problem. Okay, so the next problem, it says that there are lines, so y is equal to x plus 2, 4y is equal to 3x plus 6, and 3y is equal to 4x plus 1 is be the three tangents to the circle, whose circle is basically like this. Okay, so how to solve for this? This is a condition of circle and a tangent. Okay, that is a very, very simple problem, but this problem keeps on repeating. This particular concept goes on repeating. It says that there is a circle with a center h comma k and the radius is r. So if it is a tangent, the perpendicular drop on this tangent, the perpendicular distance from the center on this particular tangent line is basically equal to r. So for any two of the straight line, you basically equate it, you'll basically get to the value of h and k. Okay, so if you do so, okay, so if you go on doing so, you'll basically get the radius value. So now how to solve this particular? So let me first draw all the lines. So this is a line y is equal to x plus 2. So and the second line, which is basically given as 3y, sorry, the second line is basically equal to 3y is equal to is basically equal to 4x plus or 1, and the third line is given by 4y is equal to 3x plus 6. Now since these are the three tangents, they are intersecting individually as well. So if you solve it for the intersection point by solving this particular equation, that is, let us solve for the first equation, that is x minus y plus 2 is equal to 0, or not like this, or I will say like y is equal to this value, and 3 times of y is equal to 4x plus 1. So if you multiply this particular equation by 3, then is equal to 4x plus 1 is equal to 3x plus 6. So from here you get the value of x is equal to 5, and similarly the value of y will be equal to 7. So the first point of intersection is 5 comma 7, and so on. If you solve the other equations, you'll get the other values, that is this value will be getting as 2 comma 3, and similarly this value will be getting as minus 2 comma 0. Okay, now our task is basically to calculate the length. So if you calculate this particular length, you'll find it as 7 root 2, and this all intuition is coming out like how to solve it better in a geometrical fashion. Okay, so now then if from here you will get this particular value as 5, and similarly if you calculate this also value will be equal to 5. Now when is the situation that is the length of a tangent is basically similar, that there is a case that the length of the tangent is basically equal, that's the case. Okay, so if you are drawing a circle, okay, like this fashion, and if you choose this particular point P like this and this Q like this, and these particular lengths are equal, okay, then this is a very special case where this particular quadrilateral is a special quadrilateral, and if you form this triangle, this is a basically a equilateral triangle. It happens to how to be an equilateral triangle. Okay, now what is the h comma k? So if you see that this is basically, if you enclose the circle inside, if you enclose a circle inside, you basically get to the circle, and h comma k is basically the circumcenter of this particular triangle. That's what I'm trying to make you understand. Okay, so that is the circumcenter. So it is basically the yeah, it is a circumcenter. Okay, if I'm not wrong, sorry, not the circumcenter, it is basically the incenter. Okay, not circumcenter, it is the incenter. Okay, very sorry for that. Okay, so we know circumcenter is basically if your triangle is there and then you enclose a circle, this is circumcircle. Okay, and the center of the circumcircle is basically circumcenter, and this is basically in center. Okay, because circle is inside. Okay, that's wrong from my end. Okay, so you just need to memorize all these things. Okay, just know the geometrical implications of these things. And for this, if h comma k is the incenter, we know the formula for incenter is basically equal to h comma k will be equal to, so we have the sides length as well as the coordinates. So the incenter will be equal to a into x, so 5 into 5 plus 5 into minus 2. Okay, 5 into minus 2 plus 14 root 2, that is 7 root 2 into 2. Okay, so that is 14 root 2 divided by the sum of the sides, that is 5 plus 5 plus 7 root, that is 10 plus 7 root 2 comma the other coordinate will be equal to, so if you put 30, the other coordinate will be equal to like 5 into, so firstly it will be 5 into minus 2 and sorry, the 5 into 0 and 5 into 7, that is 35 plus 0 plus, and that will be 3 into 7 root 2, so that will be equal to 21 root 2. Okay, 21 root 2 divided by 10 plus 7 root 2, and that gives the center coordinate. But in the question it is asking me to find for the sum of the center, the sum of the x and y coordinate to center coordinate, that is h plus k. And if you sum up this value will be coming out as, so this value is 25 minus 10, that is 15, 15 plus 30, 35 is basically 50, and 50 plus 14 and 21 will give you 35 root 2 divided by 10 plus 7 root 2. Okay, so now 10 plus 7 root 2, so if you multiply this particular equation by 5, you basically get it. So if you have to multiply the denominator, you have to also multiply the numerator, and in doing so this particular term will get cancelled out, and the answer will be equal to 5, and the answer will be equal to 5. Alright, so that's very simple problem. Okay, but the intuition or the intuitive idea is very important, that is option number C is the right answer. How did I approach this particular problem? This particular way of approach is also very important. This problem is very important problem, mark it. Okay, because there is a geometrical implication associated with this particular problem. Alright, so let us move to the ninth problem, and the ninth problem has to say that if you have a, so the let the tangents of a circle at point A and B, so of this particular circle intersect at point C, and then the radius of circle whose center is C, and the line joining A and B, and the line joining A and B as its tangent. Okay, so if the circle has uh, so whose center is C and the line joining A and B, and the line joining A and B as a tangent, then what is the radius of the circle? So that is a pretty simple case. So if you have a circle like this, okay, if you have a circle like this, and it is saying that at point A and point at B, we are basically drawing the tangent, that is 4 comma minus 11 and 8 comma minus 5, we are drawing the tangent to this particular circle. So the tangent is like this, and they intersect at C, and this particular, and then you have to draw a circle which has a center at C, and it will have a tangent AC, okay, AB. Then what is this particular radius? Okay, if it is center, this is the radius of circle, we need to find for the radius. That is very simple. That is basically, if you get to the equation of AB, if you can get to the equation of AB, because equation of AB finding is very simple. Equation of AB, so what is the equation of AB? That is y minus 4 is equal to x minus of, sorry, y minus of x coordinate, that is y minus of minus 11, that is y plus 11 is equal to x minus 4, and multiplied with the slope. What is the slope? That is 8, that is, this is minus 5, okay, this is minus 5, okay, let me write it clearly. This is, oh sorry, I chose the wrong color. So this is minus 5, so minus 5 minus of 11, that will give you plus 6, and plus 6 divided by 4, so that is 6 by 4. Okay, so that radius is 6 by 4. So from here you get to the equation of the line AB as y plus 11 into 2 is equal to 3x minus of, sorry, minus of 12. Okay, 3x minus of 12. So from here you get to the equation as 3x minus 2y, 3x minus 2y minus 34 is equal to 0. So that is the equation of the line AB. Now you need to get to the coordinate C. So for getting the coordinate C, C will act as a point from which the AB will be a chord of contact for the particular circle. This circle, let me represent the first circle, this particular circle as C circle, okay, as C circle, or C dash circle. Okay, so for C dash circle, the AB is a, from the point C, AB serves to be the chord of contact, and we know that the formula for chord of contact in the transformation parameter is basically t is equal to 0. So if you put t is equal to 0, so for, let me assume the C coordinate as h comma k, and if you put the, if you try to find out the equation of AB as t is equal to 0, so that is x into h plus y into k plus minus 3 by 2 x plus h, okay, plus 5 plus y plus k, because it is 10y, so I've divided by 2, and minus 15 is equal to 0. Now this particular equation again represents the same equation that I found out, that is basically the equation was 3x minus 2y minus 34 is equal to 0. So these both equations are similar equation as well. Okay, now on comparing, we just need to compare for the coefficient of x and y. So on comparing, this will be h minus 3 by 2 minus 3 by 2 by 3 is equal to, for y coefficient, on comparing the y coefficient, it will be k plus 5 divided by minus 2 is equal to, for the constant part we'll get 3 by 2 h plus 5k minus 15 divided by minus 34. Now on solving it, on this particular solving, if you solve this will be equal to 3k plus 2h is equal to minus 12. Okay, and also on solving, you will basically, you are doing this by comparison method. So this is minus of 2h plus 3 is equal to 3k plus 15. Now you have this one particular value and the second particular value, so you on comparison, so you can write in this particular variable only. Okay, so same thing. And also from this particular value you will get it as 17 into this will be k plus 5. Okay, so this will be k plus 5, okay, is equal to minus of 3 by 2 h plus 5k, okay, minus 15. Okay, and this is the same value, so we are just multiplying it. Okay, and this will yield you the result, that is 12k plus 3 by 2 h minus 100. Okay, minus sorry, equal to minus 100. Okay, equal to minus 100. So from here if you cross multiply by 2, then it is minus 200, and from here you'll basically get on solving. So this is the fourth, so let me write this as equation number 2, and also we already have one equation, that is this particular equation. So on solving the equation of 1 and 2 for the values of h and k, you'll basically get two variables h and k. So you can definitely solve this. Okay, so you can solve this equation. So what I have solved in myself, I got the value of h as 8 and the value of k as minus 28 by 3. Okay, you can definitely solve it. So I got the point c, so I got point c as 8 comma 28 by 3 minus 28 by 3. Okay, so point c I got, and I have the equation of ab. Now let us get to the radius. So the radius will be basically the perpendicular distance. So the radius will be equal to the perpendicular distance of point c from this particular line, and that is given a modulus of ax plus yb plus the constant divided by square root of a square plus b square. And if you apply this particular formula, you will get 3 times of 8 minus 2 into minus 28 by 3, and what is the constant? The constant is minus 34. So divided by square root of 9 plus 4, that is 13. So if you solve this, you will get the value as, so you can definitely solve it on yourself, that is 26 by root 13. So 26 by 3 root 13. Okay, 26 by 3 root 13. So this will be coming out as, so if this is also 13 into 2, so this is 2 by 3 root 13. So the value will be 2 by 3 root 13. That is option number A. So this is how simple it is. Okay, so that is option number A, which is the right answer to this particular problem. All right, so I hope this particular problem was clear. Now let us solve the last problem, that is the 10th problem. Okay, so this is a very simple problem again, so you can solve this particular problem on yourself as well. Okay, so let us try what the question is trying to ask for. Okay, now it is saying me that O is the origin such that and OP and OQ be the tangents to the circle. So there is a circle like this way. Okay, and it is saying that O is the origin and OP, okay, OP and OQ are the tangents to this particular circle. So O is over here and P is over here and Q is over here. Okay, so the O has 0 comma 0 at the point P and Q. Now if the circumcircle of the triangle, if the circle of the triangle O, P and Q passes through this particular point alpha comma 1 by 2, then what is the value of alpha? So you just need to find for the value of alpha. Okay, so how to solve for this? Okay, so that's a good question, I would say. Okay, so if you know, you can easily solve this particular problem. Okay, so if you know for the circumcircle equation, okay, which basically includes the point origin. Okay, and for this particular, let me firstly find for the center of this particular circle. The center of the circle is basically 3 comma minus 2. The center of the circle is basically 3 comma minus 2. Now we have to find for the circumcircle of the triangle, which basically triangle is OPQ. So this is a circumcircle kind. Okay, so this will be a circumcircle. Okay, so you can have two approaches for solving this particular problem. The first approach is can be a family of circles approach. Okay, because if you have the equation of PQ, how can you have the equation of PQ? Because PQ is basically the chord of contact for the origin, that is the O point for this particular circle. Now if you have the chord of contact equation and you have the circle equation, you can assume the family of circle as S plus lambda L is equal to 0. So this will give you the variable circle equation. And for variable circle equation, what you can try out is basically that it passes through alpha comma 1 by 2. But since it lack one value, that is alpha, okay, it is better not to go by this particular approach. Okay, now that was the approach that I was thinking at first. But what I can also do instead, that I can directly write the equation of circumcircle. So if you have studied equation of circumcircle, so what I can approach I can apply is the equation of circle that is directly comes as x minus x1 into x minus x2, that is x minus 0, and the x1 point, that is the center point. So if I have the center point over here, and if I like join these particular points, okay, so if I join these particular points, okay, and then I complete this particular, okay, as a circle, because because if you know the geometric implication, because there are geometric implications along with. So let me write the geometric implications. Okay, so if this is a circle, okay, and if the origin is like over here, so if there is intersecting at this and this is the origin, so like from the center of the circle they are normally pass and this will be perpendicular to each other, and similarly the case will be like this and this will be perpendicular to each other. Okay, now if I try to form a circle, which basically encloses the point PQ, this is a point P, this is a point Q and O. So if enclosing this particular point and circle, okay, I'll get this particular circle, okay, like this particular circle, and this particular circle has a very special feature, okay, such that because these particular angles are at 90 degrees to each other, so this particular circle will basically form like a kind of a director circle. All right, so if you have studied the properties of circle, then you are basically directly you can write this equation of circumcircle as x minus x1 into x minus x2 plus y minus y1 into y minus y2. So by considering this as the center and this as the center, okay, these are the two endpoints of a circle. Considering the two endpoints of a circle, because I consider the two endpoints of a circle because my drawing was not very clear, because this particular part, if it encloses this will definitely pass to the center of the circle. It will definitely pass to the center of the circle, and this will make this particular right angle be enclosed in it. Okay, so this particular right angle is enclosed and this particular right angle is enclosed, and that's how the equation of this particular circle are basically simple. That means these two circles are basically director circle of each other. Okay, so that's the idea. Because and if it is 90 degree and this is 90 degree and this is also 90 degree, this will be again a 90 degree at each other. That means the locus of the angle between the two tangents for a circle, if it is 90 degree, then it is basically means it is a director circle. And no, sorry, what I'm saying, okay, very sorry, not I'm director circle, okay, I'm not talking about the director circle, because sorry, I'm very sorry, because for 2 points passing through, for a circle passing through 2 points, I can apply this 2 point approach. Okay, the 2 point equation of a circle passing through 2 points, and this is a geometric principle. I'm very sorry, why did the concept of director circle come into my mind? I'm sorry for that particular thing, okay, because I was thinking in different terms. Okay, it may not be at 90 degree each other. Okay, so we know that if the circle passes through P, Q and O, it will definitely pass to the center of the circle. Okay, it will pass to the center of the circle, and if it is passing to the center of the circle, we do have 2 points, which is basically, and this O and the center of the circle C is basically the largest chord, and that basically implies the diameter. So if I have the two endpoints of diameter, I can definitely write the equation of circle, that is PQR circle, as x into x minus 3 plus y into y minus or minus 2, that is plus 2, is equal to 0. So from here I got the equation of circle as x square plus y square minus 3x plus 2y is equal to 0. Okay, I'm very sorry for what I'm speaking. I was thinking of some solving it like in the fashion of a director circle. Okay, things happens. Okay, things happens. And then I know that alpha comma 1 by 2 lies in this particular equation circle. So let us put back. So alpha square minus 3 alpha plus 1 by 4 plus 1 is equal to 0. And from here I get a quadratic in alpha, that is 4 alpha square, okay, minus 12 alpha plus 5 is equal to 0. So from here the value of alpha is basically 12 plus minus root under 144 minus 4 times of 20, that is 80 divided by 8, and this will be equal to 12 plus minus 8, this is equal to 64. So plus minus 8 divided by 8, so the alpha value, the first value of alpha is basically 20 by 8, that is basically 5 by 2, and the second value of alpha is basically 4 by 8, that is 1 by 2. So you got to the values of alpha. So the alpha value is, one of the alpha value is basically 5 by 2, and that's option number C. Alright, so this is again a very simple, pretty simple problem. Okay, so if you know the geometric implication, that whenever you get a two tangents and which is enclosing a triangle, and then you have to find for the circumcircle of that particular triangle, then definitely we enclose the point O. Okay, so you can have the proof of it. Okay, if you are someone who is very curious why it will pass to the center of this particular circle, you can definitely get the proof, okay, by yourself, because this part, if I'm saying that this particular angle is 90 degree and this is 90 degree, you can get the proof from this particular hint. Okay, if you haven't studied the chapter circle, then you can directly memorize this particular property. Okay, but I won't say that memorization is a good thing, because in examination you might forget. Okay, so with this I come to the end of the 10 important previous year question on the topic of circles. Okay, so that was my take on 10 important problems on circle, and as you have seen that the problems on circle was not very simple and straightforward. They were calculative, they were lengthy, but they involved this only few concepts. If you know the concepts, you are basically able to do it. So I can suggest you that if you are revising circle chapter, what important thing you must need to look for, that is the equation of tangent, equation not the equation of normal, because there is nothing equation of normal you need to worried about. Equation of tangent, okay, the point of contact of tangent, okay, you need to look for the number of tangents, common tangents, okay, you need to look for the transformation that you basically do, that is the chord of a given, with a given midpoint, chord of contact. Okay, so those things you must need to be very careful about. And the other important thing of circle chapter is basically family of circle. So with this I will wrap up my